Another 2 minutes, we'll start. Previous class is not over.
Sir, some people are facing difficulty in joining. So they're saying it's invalid meeting ID or something.
Oh, okay. Okay, we can start. It is already 6. Can I start? Still very less people today.
Sir, it is showing the meet link is invalid to some people.
Why? How then you have joined?
I don't know, sir. I joined
From mobile, sir.
No, sir. I have joined from laptop. No issue about it. Still showing to some people. Invalid meeting ID.
Update करना है.
Because of that. Okay. Just 1 minute, then we'll immediately start. Yes. So last class we discussed about how can I make this hardware lock. So one kind of hardware lock we have studied, that is a CLI and STI. Is anything? No. CLI and STI, where one has to disable the interrupt and again one will be enable the interrupt. And this CLI and STI is basically the instructions of the CPU itself, so that directly it can be used and nobody can interrupt this. One thing we have observed that it may be very easy, but in some cases it is not suitable. Like if user level threads are going to run, it may not use this kind of locks properly. And if since you are disabling the interrupt directly, if some problem occur because of some logical region in the critical segments, the whole system is going to be hacked. Okay, so next kind of hardware lock is called as the test and set. Test and set. This is another kind of hardware lock. Just look into it. Very interesting, this one. So this function has written like this: test and set. It is taking a parameter called as, let's take a lock. And what it does, it basically store in a temporary variable int temp equal to star lock. And it set this value like star lock is equal to 1. And he return this temp. Okay, very simple function he has written. So it's taking a address of this lock variable, and he can directly take if lock becomes global, doesn't matter or not. So he is using now storing the value inside this temp and make this lock equal to 1. After that lock equal to 1 and return this temp. And what is the lock here? Because you have to write again what is the acquire lock and a release lock. If you can go for the acquire lock, in this acquire lock, basically he is saying if there is a while loop where test underscore set this ampersand lock. If it is, then it is a loop. So this is our acquire lock. And what is the release lock? This is the acquire lock, and the release lock is like this. The release lock is basically in this manner, lock equal to 0. Yes, or lock equal to 0. And what is this lock? There is a int lock initially becomes 0. Are you getting what I told? So this is my function, and this is my acquire lock, and this is my release lock, because you know that our critical section will be here. Yes, means before you enter into the critical section, you have to acquire the lock, and once it is over, then you have to release this lock, whether it is achieving the mutual exclusion or not. So first you have to look into it. Yes, because that is our main criteria. So let's take lock becomes 0, and first process wants to enter into this area. Then what it does? The lock is 0. He has to execute this particular function. So when this function gets executed, you just look into it here. So lock is becoming 0. This temp is 0. Lock is set to 1. So it is changed to 1. Okay. Then it is temp is written. So temp is 0. 0 is written. So the whole value becomes 0. Since it is becoming 0, then you can say that it is while 0 means false. False means it is not put in a loop, directly come here. Everybody understood the simple code for the P1 process? Forget about P2 anything. Only one process, whether he is eligible to enter or not. First thing. Or koi nahi enter kar payega, there is no meaning of this kind of lock. He is saying, so first lock is 0, I told. This function has to be put in a loop. Okay, this is in a loop. And if this loop becomes true, then it is infinite. If loop becomes false, obviously it will not in an infinite come out. So since lock was 0, so value is stored in the temp as a 0. Lock is set to 1. Now it is become 1, and a return temp means return 0, because temp value is 0. So this whole value is become 0, while 0 means false. False means it will be come out from the loop. Once it will come out from the loop, then critical section executed, again he becomes set of 0. But now we have to check when somebody is present in this critical section, can a P1 or P2 can enter into this critical section as per this code? Yes. Let's look into it. Suppose he is here. When he is here, what is the lock value? Lock value is 1. Then P1 wants to, P2 wants to execute here, because P1 currently present here, and P2 wants to enter here. So P2 has to be execute this code. While executing, he has to be pass this lock. Lock value is coming here. Then lock is now currently 1. Temp is becoming 1. Lock is still 1. And return temp, return 1. Return 1 means what? He is in the loop. Then who is putting in the loop? The P2 is put in the loop. whereas the P1 is currently executed. Now, unless until this P1 make this lock to be 0, this P2 is still in this loop. Means he cannot enter into this area. So this is basically a test and set lock. Let's see one example where some problem is there.
Sir,
Yes? Pujay.
sir, here another problem can be, sir, here that test set. So there are three statements, and sir, and there is no synchronization of that lock is equals to 1.
No, not an issue, not a big issue. Only one problem you can find out, because you think about that since it is a lock is a shared variable, it has to be synchronized. Very nice observation you have made. Forget about this. Suppose we don't know those kind of things. Suppose the two persons, suppose first person comes here and try to check this test and set lock. He comes here. First time, what is the value? 0. Then who has entered first? P1. After P1 enter into this area, let's say context switching is happening. It is possible or not?
Yes, sir.
What I told here, I told P1 is already entering into the critical section and P2 enter. Then I assure that P2 cannot enter. That's okay. But it may happens, P1 first time comes, try to enter into the critical section. He has to go through this acquire lock. While going through this acquire lock, this function has to be executed. While executing this function, suppose first line he has executed. Who? P1. And that time context switching is happening. If the context switching happening, what happened? Again P2 comes. At that time still the lock is 0. So temp is a local variable. Since it is a local variable, can you say if there is a T1 and a T2 threads both are executing this, temp will be same for both or different?
Same.
सोच के बोलिएगा, ऐसे नहीं कि मैं पूछ रहा हूँ. Same or different? अलग अलग होगा या same हो जाएगा?
सर सेम हो जाएगा उस इंस्टेंस में तो.
Let's take again. I'm repeating. Let's take T1 and a T2 are the two variables, and a T1 enter here, execute this line. After that context switching is happening, T2 also enter, execute this line. Can your temp will be same or different? दो बार पूछ रहा हूं. Others please answer. ये पूरा पढ़िए. अगर ये बता नहीं पा रहे हो, पढ़ाई नहीं हो रहा है. It's the same or different? Please tell me what are the things are common for multiple threads and what is unique?
Sir, because it is not updated.
No, I'm not saying. I'm saying the memory location for the temp for T1 and a T2 will be same or different?
Different.
Different.
Why?
Sir,
Why
because
you-
it is thread.
Not thread.
T1, T2 are the two threads. Do you think that it will be different? T1, T2 both are using the address space of the same parent.
Sir, the stack space will be same now for both.
Very nice.
So,
That is the first point. Because your local variable is stored in the stack. And as per the thread is concerned, I told that every thread has their own stack. Yes or no? Even if the threads are using the address space of the parent, but the stack and the program counter and the CPU state of each thread is different. That's why the temp for T1 and temp for T2 both will be different. Okay? Yes. Now what happens? The temp becomes, so for this the temp will be 0. For this also the temp will be 0 because lock has not changed. Lock is still 0. So if it is becoming 0, the T1 execute this line, lock set to 1. T2 also execute this line, lock set to 1. Then returning temp by T1 and returning temp by T2 for this particular function. Then what value will be returned for T1 and what value for the return for the T2? 0 or not? In both cases 0 because you have made a context switching is here. If the context switching will be applied at this place, both of them have executed this line. If both of them are executed this line, then lock value will be that time what? 0. Means temp value will be 0. If temp value will be 0, then what value they are returning at the end? 0. So while 0 means false. False means what? P1 also entering into critical section, P2 also, or T1 also entering into critical section, T2 also entering into critical section. Means both of them are currently present in the critical section, but we don't require. Then how it is happening? He's saying that this is a very nice code. Previously we have just seen once the T1 enter, when the T2 is coming, the T2 is not allowed to enter. But when the problem comes because if there is a context switching is happening here. If the context switching is happening here, there is no issue at all. If you look into it, suppose P1 comes, set the temp will be 0, then the lock will become 1. And after that, context switching is happening. This function has not completed. The context switching is happening at this stage. Then what happens? Again, T2 comes. What is the lock value of T2? Lock value is set to 1. 1 is stored in the temp. Then for T1, the temp is 0. For T2, the temp is 1. Means when this function will be returned for T1, it returns 0. When this function returns for the T2, it returns 1. Then since for T2 it is returning 1, the T2 is in the loop. Since for the T1 it is returning 0, the T1 has to come out. Means T1 will be enter and T2 in the loop. If the context switching is happening here. But since it is a 3 lines code, you cannot say that, sir, after 2 lines only the context switching gets happened. It may happen the context switching after first line. If after first line it is occurring, then guaranteed it will be what? Both will be enter into the critical section, which is not allowed. But it is a code. Then how we can say? And the next question somebody asks, sir, you told about the hardware code, but now you are writing a software kind of things. Yes or no? I told that it is a hardware code. Now previous things, is it a hardware code? Yes, sir, it is a hardware code. Why? Because you are using a CLI and STI. What is the CLI and STI? These are the direct instruction. If you can go to this particular XP6, you can find one code called as a CLI and ASM. And you know, any assembly language instruction, when you want to execute it in a C, you have to write ASM and that instruction. So the CLI and STI are the 2 different instructions. That's why single instruction will be executed in a single clock cycle. So there is no interrupt will be happening. Because in previous case, there is no interrupt. When the CLI will be executed by somebody, that time nobody cannot be entered into the CPU. Because it is a single instruction. At least one instruction must be complete. Then only the context switching is going to happen. You cannot say that in the middle of the instruction, the context switching is happening. But in this case, what? Whatever the test and set I have written, that consists of some 3 or 4 instructions. If there is a 3 or 4 instruction, if the context switching is happening after first instruction, guaranteed that will be a violating this mutual exclusion. Then what you need? I don't want any context switching should be happen here. If don't want, then what you need? This should be a atomic. What do you mean by atomic? The atomic says that there is no, it is an uninterruptible operation. Yes. So he is saying if this 3 lines code will be atomic, then my critical section mutual exclusion will be guaranteed as it. Why? Because atomic code means during the execution of this code, no interrupt can be generated. Yes, no interrupt. But how is it possible? There is a 3 instruction, and you can say, sir, you put a lock here and you put a lock here. But for that lock also you have to write another lock. Because for a lock, I need another lock. For that lock, I need another lock. Then it is infinite. It will never stop. And how I can make these 3 lines to be a atomic? Then that's saying, why don't you make these 3 works in a single instruction? Yes? Why don't you make these 3 lines in a single instruction? Means 3 work you do in a single instruction. What is doing? He is setting and also testing, because by return he is testing and setting is by lock equal to 1 becomes setting. If the test and set both has to be used in a single instruction, then it is possible. And that is actually achieved by, there is a called an instruction TSN, test set instruction. So TSL is one instruction. Like CLI is one instruction, move add is one instruction, MOV is one instruction. Similarly, there is an instruction called as a TSL. The TSL work is to do all these three things at a time. If these three things will be done at a time means in a single instruction, guaranteed when P1 is going to be executed here, P2 cannot interrupt in the middle. Once this P1 completes its job, these three lines, then only the P2 comes. When the P2 comes, obviously already this lock becomes set to 1. Once it is set to 1, he will be in the loop. Okay, so that is called as a test and set hardware lock. Yes, the test and set hardware lock working like this, but internally it is considered as atomic. What is atomic? It is an uninterruptible operation. Uninterruptible operation means during this instruction, no interrupt is going to be occurring in the middle. How is it possible? Make these three things has to be done by a single instruction. And you can find in many architecture, there is an instruction called as a TSL. Okay, understood? So this is the point by which we can also achieve it. But one observation, very interesting observation here, very important also. That is, when T1 is entered into this critical section, the T2 has come. The T2 could not enter, but this is a code. What the T2 has to do? The T2 has to be try this code repeatedly. Yes or no? Because T1 is doing his work here. At the same time, T2 is also doing the work here. For this moment, T2's work is this function. For this moment, T1's work is this function. And both are the processes. If both are processes, both are running simultaneously. If both are running simultaneously, the CPU has to be divided its quantum time among these two processes. Then what happens? Unnecessarily, this T2 is busy with this lock. Means he is repeatedly checking. Like somebody has entered into the toilet. He knows, the outside people knows that he is inside. Still he is knocking. He is making him bored. Then what will do? It is he is wasting time because he is getting disturbed. The person who is inside the toilet, he is getting disturbed. Neither he is also come out. Yes. Then what is necessary? If you could not disturb, then at least he will be finish his work and come out so that he can enter. But what happens? He is making it busy. For whom? Busy to the CPU. Because the CPU is also busy with testing whether he can able to enter or not. And that scenario is called as the busy waiting. Or sometimes it is also called as spin lock. So what is a spin lock? A process is waiting for the lock. Waiting for spinning in the lock. Means to acquire the lock, he is spinning inside this lock. Neither he can enter nor he can come out from this. He is spinning in that area. What is the problem? The problem is that he is eating more CPU time here. Unnecessarily, he is eating the CPU time just to check whether I can able to enter or not. So actually, the person who is present here, he cannot get a chance more to execute. Once you will get a chance, then only you will execute and come out. No, but he is not getting a chance more. Why? The reason is that CPU, when it is divided some quantum time to him, some quantum time to him, after few minutes of execution, CPU is again busy with this lock. So what the solution? Then this spin lock creates a problem because spin lock is consuming more CPU time just for checking this lock. Then what the solution? The solution is like this, what they're saying. When a person is present inside the critical section, if another person is coming and checking in this lock, instead of running this lock repeatedly to enter, why don't you bring this process to a queue called as wait locking queue? Or sometimes it is called lock waiting queue. Lock waiting queue. Yes. Then what is the job of this lock waiting queue? The T1 is present inside this critical section. T2 checks that whether lock is open or not. Since first time it checked that it is not open, then the operating system bring this process to this one and make him to sleep. Yes, he will make him to sleep. So if he is going to be sleep, then he will not disturb. Then what will happen? The moment this T1 will be finish his work and release this lock, then he will be wake up these processes. Then what is the benefit? The benefit is that the process will be now wake up. He is not disturbing while P1 has entered into the critical section. So this is the important solution for this. But there is again one confusion. The confusion is that whether this process is good or better to spin in this lock will be good. That is a two scenario. If my critical section is very small, then the spin lock will be better. If my critical section is very small, what is saying? The spin lock will be better if the critical section is very small. Is it possible? Because yes, it is. Because if my critical section is hardly a one line code, let's assume that. Yes, hardly a one line code. Then what happens? When P1 is entered here, if P2 wants to enter here, then P2 try to enter, he could not enter because test and lock, test and set function returns 1. Then P1 which is entering, he will get a chance after this quantum time. Once it will get this quantum time and execute, then since it is a one line, immediately it will be completed. Then this P2 process again quickly enter. Then you can say, sir, this process is also good. This is a very nice process. A process when it is locked, you bring it to this queue, make him to sleep, and whenever he is finishing this work, and he has to get up. But see, what's the problem? The problem is, if it is very small, still you are saying that this P1 process has to, P2 process has to be entered into this queue. Then the problem is to bring this process to the queue, make him to sleep and wake up. All these things consume more time. Means after finishing this process, this critical section by this P1 process, still a lot of time is spent for making him to sleep, making him to wake up, bringing this process to this place to execute. So that's why in every scenario, this kind of lock waiting queue may not be suitable. It will be suitable if your critical section is very high. Your size of the critical section is little high, then it is good. But if your critical section is very small, then you may not prefer this kind of lock waiting queue. Rather, the spin lock is also a good choice at that moment. Please remember this. Yes, and never say that the spin lock is always bad. The spin lock is good if my critical section is less. So that is called as busy waiting or spin lock. To avoid the spin lock, we use a lock waiting queue, and exactly we can see in the XD6, they are maintaining this lock waiting queue, spin lock. Exactly, you can find there is a spin lock.h function is there. Yes, just for showing you, I have just opened. There is a spin lock, push CLI, and some functions are present in the spin lock.c, which is maintaining this one. Okay, so this is about the two kinds of hardware lock. There are many such, but most important one are this test and set and CLI and STI. Yes, in your book also you can find one more lock, that is a compare and that is called as compare and swap. Yes, just go through this. No need to ask me. Just compare and swap. There is another kind of hardware lock. Yes, just read. It is nearly equal to the test and set. Please go through this. It is a 3 lines code. Because you know the gist of this, how it is happening. It requires atomic, why it is atomic, and it is making a busy. And another interesting thing, such when a problem comes. Suppose assume this P1 has entered into the critical section and the priority of the P1 is 2 less, and your system is using a priority level scheduling. Then what happens here? This after P1 enter into this, the P2 try to enter, and whose priority is too high. Then what will happen? The CPU is giving the time to P2. But still this P2 cannot enter into this critical section because P1 the time he is not getting the CPU because of his low priority. He has already entered, but he could not come out because the CPU is not giving time to him. To whom he is giving? To the P2 processes. And what the P2 is doing? Unnecessarily he is eating the time of the CPU just to enter into this critical section. But he cannot get it unless until the P1 himself finishes work with the help of the same CPU through which the P2 is working. Okay, that's right. Now we'll go for one interesting software. Yes, ask.
Sir, yeah, so the round robin is also priority based.
No, round robin, pure round robin is not priority based. The pure round robin last class I told it is FCFS.
Yes, sir.
Yes, but no what the operating system, almost all operating system using priority along with that. Okay, round robin. Not only
Sir.
this.
Sir, and another doubt, sir. Here that thread you were telling that int temp is starlock and that address is same. Sir, you meant that virtual address.
Oh, this no. It is obviously whatever the address you are finding for the temp, it is a virtual for us as a C program.
Sir, but that but the two stacks will be in different location in the same stack now.
Two stacks will be different location. And we have studied that when two threads will be created, their local variable will be separate. Because local variable stored in the stack means stack agents.
Okay, sir.
Okay. So next important, which is a long question that is called as software lock. Everybody clear about what is the spin locks problem and busy waiting? Understood or not?
Yes.
Yes. So the first only one software lock is in your course, that is called as a two process software lock. Or it is basically called as Peterson's two process solution. Yes, very, very powerful. And how he is solving this particular problem just means he is now using a software. Software means you will write down a normal code like A plus B, A compared with the B like this. He will not use a direct instruction like CLI, STI or this TSL. He is not using a direct instruction. He will write a simple logic in such a manner that if one person enter into the critical section, another person cannot enter. Let's see what's the code. So assume that there is a P1 process and there is a P2 process. Yes, and he is using some variables. So first variable he is using a Boolean flag, which is 2, and Boolean flag is set to 0. Yes, one more variable he is using that is called as int torn, and the torn equal to int torn. So you can take that torn int torn. No need to do anything. Okay, so two variables, and how the code he has written. Just look into it carefully. He has told the flag 0 means if you can take it is a P0, and if you can take a P1, then you can say that a flag of I. It is the ith process. Ith process is becoming true, and he's saying the torn is equal to 1. Then he's saying a while if flag of 1 is true is equal to 2. T means true, and torn is equal to 1, then I'll be in the loop. Yes, so this is my entry section. This is our entry section. Yes, so here also how he has written the same thing, flag of 1 is equal to true, torn is equal to 0. Just change little bit, compare. Then he is making while this flag of 0 is equal to true and turn is equal to 0, then it is in loop. So this is his intersection. Okay, this is for his intersection. And what it does, then they are using the common section. The common section is critical section. Okay, critical section. And their exit section. So what is their exit section? He is saying I'll set flag of 0 is equal to false. And he is saying I'll set flag of 1 is equal to false. Okay, so this is basically the exit section. Okay, now how this progress, bounded weight, mutual exclusion, all these things are achieved in this particular solution. Okay, let's prove this one. And what is the meaning of these variables? Please concentrate. I am telling one by one. These are the two variables, and what is the use of this variable? So first, this flag is saying that he is interested to grow. The flag is basically says process is interested. Interested to enter critical section or not. And turn is basically allowing to enter. Yes, these are the two things. Then if we can observe here, the flag 0 is completely modified by P0 only, and flag 1 is modified by P1 only. Means in some cases, when P0 wants to enter into this critical section, he first says that I am interested. When P1 wants to enter into the critical section, he says that I am interested. Okay. Before entering to the critical section, a process says he is interested to enter. Once it is told, then they are very genuine person. They are saying, even if I am interested, the P0 is saying, I will give a chance to one to enter. Yes, it is not a monopoly they are doing. They are doing very genuinely. He is saying, I am interested to go, but I will allow let's one to go. He is also doing like this. He is saying, if P1 wants to enter into the critical section, he has to be definitely say, I am interested. But he will not directly enter, rather he will say, 0. If you want, you can go. Okay, so very genuinely both of them are saying. After that, they are verifying one case. What is the case? If at this point, when he wants to enter, just before enter into the critical section, he is just verifying that if one is interested and currently one is allowed to enter, then let myself to be wait. Are you getting my point? What is this while loop says? While loop says if flag 1 is true, means if 1th process is interested and currently turn becomes 1, then please you enter, I will be stay here. He is in the loop. In the same manner, this while loop P1 is saying, if 0th process is interested, if it is equal to true means, if he is interested and currently allowed to 0 only, then let myself to be in wait here, and he has to be enter into this critical section. Very nicely, there is no such fighting, nothing. Everybody before entering telling others that if you want, you please go. After that, I'll go. Yes, there is no such conflict. Now you have to prove here that if P1 person is present in this area, P0 cannot enter. Or if P0 person is present in this area, P1 cannot enter. Are you getting my point? Yes. So that you have to prove it now. So let's see how we can prove. So the kind of contradiction proof we have to make it. Yes, let's assume that the P0 is entered, already present here. Mutual exclusion says that if one process is present inside the critical section, another process cannot enter into this critical section. Okay, but it is a software code. Exactly this kind of code will be written when you write down the program for this. Exactly. In a flag of 1 equal to something, then like this you apply it. Now observe what is happening. So very nice. So if P0 is entering, this P0 is entering, then P1 cannot enter. When the P1 cannot enter, the if this condition will be true. Assume that this is false. Yes, what is the contradiction? Say that you make it false, then at the end conclusion will be become false, then it is proved. So in the same manner with you, assume P0 has entered. Now you are saying that whether P1 can enter or not. I assume that the P1 can enter provided any one of the statement will become false. Yes or no? If this is false or this is false, then P1 can be entered into this. But if both of them will be true, then he cannot enter. Either any one or both become false, then P1 can enter. So what you take the contradiction first, you assume that this is becoming false. If it is becoming false, then what is the term's value? 1. Please remember. Yes, 1. If you are saying that the term is 1, if you are saying that the term is 1, yes, here you are saying it is a term is 1, means this statement will be executed after this or before this. Try to understand. Yes, what I'm saying?
Turn 0 is before turn 1.
If I'm saying that this is false and this is true, if it is becoming false, means turn is 1. If turn is 1, before coming to this line, he must have crossed this. If he has crossed this, he has set to 0. If he has set to 0, but I am saying it is 1, means this statement must have executed after this or not. Yes or no?
Yes, sir.
Yes. If he has executed after this, but you are assuming that he has already entered, means this statement is true and this statement is false. Yes or no?
Yes, sir.
Yes, because you told that this statement is executed after this. If this is executed after this, means turn is 1. If turn is 1, means this is true. If it is true, since P0 is present inside the critical section, he must have crossed this while loop. If he has crossed this while loop, one of the statement will be at least false. But it is true. If it is true, this must be false. If it is false, what is happening? Flag of 1 is false. If flag of 1 is false, means this statement cannot be reached here because you told that your process has come here. If P1 process has come here, he must have executed this to true. But here it is coming as it is false. This is a contradiction. समझ में आया? और एक बार बता रहा हूं, बहुत इंटरेस्टिंग है. क्या बताया? P0 has already entered. Now you have to prove that P1 cannot enter. Then in contradiction, always you think that less P1 has entered. How will he enter then? He will be entered provided this is false or this is false. First proof is assume this is false. If it is false, means turn is 1. When he is here, who is here? P1 is here, turn is 1. If turn is 1, means he must have crossed this. But if he has crossed this, turn is 0. But how it is becoming 1? Means after execution of this statement must have been executed. Means after execution of this statement by P1, the P0 has executed this statement. If P0 has executing this particular statement, now you can observe here. Then this is 1, means this should be true. If it is true, since P0 you have considered it is already entered into the critical section, means he must have make it false. This must have false. If it is false, then can you say that this is false, but P1 is present here, and after the P1 he has executed? Never. Because if it is becoming false, the P1 either here or here. The P1 cannot be inside. Yes or no? Because you are making this flag to be true here. This onwards it is become true and it is become false. And since here you are assuming that it is become false, means your P1 is either before this or this onwards. He cannot be inside this. Means this assumption will be considered as a false. That's why P0 cannot enter. This is first. Second proof, can you observe? Let's assume that this is become false. Can anybody prove? This is becoming false. Very quick proof. Quick proof. No need to think. Suppose because of this is false, he has entered. P1 has entered. You assume. If this is becoming false, can you think like this? If this is becoming false, how the P1 is here? P0 is here. Because if it is becoming false, then P0 will be either here or before this. But you have already assumed that P0 is inside the critical section. Means it cannot. That's why the mutual exclusion gets applied. Yes, you have to write the two proofs for this. One, you have to consider if turn is 1, what is happening? If turn is flag is 0 is false, then what is happening? Both the proofs you have to write. Then only consider it is. Yes, so by this way you can achieve the mutual exclusion. Yes, and if you can look for this, what is the bounded weight? Can anybody tell me? What is the bound here? Is 1 or something? Is there any bound?
Yes, sir. 1.
1? Yes, exactly 1. Because what is the bound says? I am interested to enter. I am interested to enter. But after that, if somebody is coming, I will allow him once. After that, I will not allow him once. So let's see how it is happening. So what is the? I am interested to enter. Means I am here. Yes, but I have not entered here. Suppose he wants to enter into the toilet, this toilet. I am standing in the front of the queue. I have just told that I am interested to enter, but immediately he knocked me that please, I am urgent. Please allow me to enter. So whether he can enter, and after that he cannot enter more. So let's see what happens. So he is here. He is standing here. He has set this flag 1 to be true. Then P0 try to enter. When the P0 try to enter, he is making true. He is making 1. Since he is making 1, then what happens here? Just here. If it is making 1, then turn is becoming 1. Turn is becoming 1. And this fellow has set the turn to be 0. Then can he will be in the loop or not in the loop? Please tell me. Are you understanding or not understanding? Please ask. I told that suppose P1 is interested, P1 executed this line, because these are the software solution. Context switching may be happen at any moment, either here or here or here, here. Any moment the context switching is happening. Let's say the context switching is happening here by knocking by this particular person. He is saying, I'm very urgent, please allow me to enter into this critical section. Yes, whether he will allow or not, if he will allow, then what is going to happen? So let's P0 try to enter, P0 execute this and execute this. Yes, after that he wants to enter, he try to enter here. So what is the condition check? Sir, flag 1 is true. हाँ sir, true. Sir, turn is 1. मैं खुद ही 1 किया हूँ sir, फंस जाऊंगा यहाँ पर. I am in the loop. Yes, then what happens? Since he is in the loop, definitely the context switching will be happening after a quantum time. When after a quantum time the context switching is happening, what is the value of this? He has said the turn will be 0. The moment if the turn will be 0, this becomes false. Yes or no? This becomes false. Since it is becoming false, this P0 will be entered into this or not. Then where he is standing? Your P1 is standing here. Yes? your P1 is standing here. Who has entered? P0 has entered. But what is the bound? Somebody told us a bound is 1. What does it mean? Means after one person enter, I will be definitely enter. He cannot enter. So let's see. He is entered, come out, and again try to enter. If he is doing like this, then you can say that there is no bound, because infinite time he is nicely entering into this toilet. He has given a chance, but after that he is infinite times entering, he will never get a chance. Let's see. After he enter and come out again, try to enter, can he able to enter or not? Let's look at it. Because yes, others please see. So P0 अभी कहां पर है? देखिए टर्न यहाँ पर 0 किया है and इसको 1 किया है. Then he is coming. He is coming here. Then makes the turn to be true. खुद का टर्न को फॉल्स किया था, फिर खुद को ट्रू कर दिया, बोला कि मैं फिर से जाना चाहता हूं. ठीक है, आप जा पाते हो कि नहीं देखते हैं. सो टर्न 1 किया, टर्न यहां पर 1 कर दिया. इसका टर्न कितना था? 0. अभी ये 1 कर दिया. Since it is becoming 1, then what is happening? Flag 1. सर flag 1 ट्रू है क्योंकि वो यहां खड़ा है. The turn is 1. सर turn is 1, मैं खुद ही turn 1 किया हूं. सो दोनों ट्रू है, यहां फंस जाएगा. यहां फंस जाएगा तो कौन आएगा? Then P1 try to enter this while loop. Then what is happening? Can your flag 0 is true? Yes sir, true है. Yes. Can your turn is 0?
1.
सर turn is 1 है, ये 1 कर दिया है इसीलिए फंस गया है. Then turn is 0. Then he can enter. And after 1 turn, guaranteed he will execute. Yes. So the bounded weight here it is 1. Can anybody prove the progress? 3 चीज. क्रिटिकल सेक्शन अच्छा है, मतलब अच्छा कोडिंग क्रिटिकल सेक्शन में किया बनाया गया, मतलब तीनों सेटिस्फाई करना चाहिए. कैन यू टेल मी द प्रोग्रेस? प्रोग्रेस मतलब क्या है? आउटसाइड पीपल कैन नॉट इन्फ्लुएंस मी. मीन्स मैं जाना चाहता हूं, अदर एक आदमी जो मेरे साथ कॉम्पीट कर रहा है वो भी नहीं है, गांव में है. कैन ही इन्फ्लुएंस मी नॉट टू एंटर? लेट्स सी. ही इज नॉट हियर, he is outside. Outside means what? He is not in this area. Either he is here or outside of this. Either he may be also reminder section outside. Yes. If it is outside means what? Flag is false. Flag 0 is false. Then he tried to enter. मतलब P0 अभी भी university नहीं है. And P1 tried to enter, come to the university. He wants to do the class. Whether it is possible or not. आया यहाँ पर. T को 0 किया, टर्न को भी 0 किया, और देखा कि फ्लैग 0 ट्रू है. नहीं है सर, वो बाहर है, घर में है. यही तो फ्लैग फॉल्स है, मतलब मैं क्लास करूंगा. यस. सो इट क्लियरली इंडिकेट्स दैट it is also achieving the progress. Means other person cannot influence or force me not to enter into critical system. So these 3 conditions get satisfied. So this is about your software solution for this. I hope you have remembered the things. No need to again. So ये 2 चीजें आपको याद रखना पड़ेगा. पहले मैं इंटरेस्टेड हूं, मैं और एक को बोल रहा हूं कि आप चले जाओ. Then I am checking that अगर वो भी इंटरेस्टेड है, मीन्स अदर पर्सन इज इंटरेस्टेड एंड उसके लिए टर्न सेट हुआ है, then I will be in the loop. I will not go in the reverse way. And you have to prove how it is happening, this bounded weight, progress, and nature expression. Okay, if you can see the recording once again, you can write down also the way I explain.
Sir, but it can only handle 2 operations, right? 2 process.
अभी तक हम पढ़े नहीं. There are many multiple operations are there which are going to study after some time. Yes, not today. In the next class by a different solution, but there is another interesting multi-processor solution is there, that is called as a bakery solution. Okay, which is not in your course. You can go through this bakery जो खाते ना bread वगैरह, bakery solution. Yes.
Okay, sir.
It is supporting the more than one process. Okay, which you are not studying here. Yes? So this is about this. Then one problem. What you have studied? We have studied, sir, मुझे critical section inconsistency हो रहा है. To avoid the inconsistency, I need again repeating. मुझे cooperating processes. So आपको याद आ जाएगा. I have a cooperating process. Cooperating process is using the shared resources. The shared resources are used simultaneously. Then there is an inconsistency. To avoid the inconsistencies, I need a synchronization. Synchronization can be achieved by make the common area to be mutually exclusive. I cannot directly make the common area to be mutually exclusive. Rather, I'll make the entry through which the common area can be accessed, that should be mutually exclusive. So that is my critical section. Then how can you make this critical section to be mutually exclusive? By putting the lock and unlock. Before the critical section, after the critical section, unlock it. But this critical section, when you design with lock and unlock, it has to be satisfied this progress, mutual exclusion, and bound. Then only it will be satisfied. Then what is progress, mutual exclusion? All these things just now we have discussed. The next thing comes how to prepare this lock. Even if lock is ready, but what are the ways to prepare this lock? There are two basic ways. One is called as the what is I told. One is called as the interrupt hardware lock, where the CLI STI is used. Another one you have studied, the test and set. But in test and set, we observe that when a process enters into the critical section, another process is knocking the door or knocking the lock, just to check whether the lock is open or not. He is checking repeatedly. And that is basically called as a busy waiting or spin lock. Means a process is spinning at the lock. Yes, the spinning at the lock. Since it is spinning at the lock, then what is our duty? Our duty is to how we can stop the spin lock so that the process which is currently present in the critical section, he will get a chance to execute it by the CPU and come out. And that can be achieved by an additional queue called as a lock waiting queue. So the moment a process knock on the door by checking the lock, if the lock is not currently open, rather than checking the lock repeatedly, let the process to be enter into the lock waiting queue where the process is going to be sleep. And once the process which is currently present inside the critical section comes out from the critical section, then one of the processes from the lock waiting queue will wake up and enter into the critical section. So that is the two software locks we have studied. And we studied also that the spin lock will be sometimes beneficial when my critical section size will be very less. Because unnecessarily I will bring a process and take in that you sleep there. Because if it is like this, no, if a flight is cancelled, obviously it will be a trouble for the airways. Why? Because they have to give a hotel, they have to pay the price for that, give the food, everything they have to give it. The same thing is happening. If my spin lock is very less, why I'll bring the people to stay in the lock waiting room and give them the pillow, give them the bed and make him to sleep. And whenever it is wake up, I have to wake them up and bring to the airport and give the seat in the aeroplane. Then a lot of work has to be done. So that's why the spin lock sometimes it is beneficial. Then we study the software. Okay, so next class we will study one more problem. There is one interesting problem I'll just tell, then why the next solution is required. The problem we studied very nicely. Sir, we put a lock and we release a lock. Yes, and this is my critical section. By this way, mutual exclusion will be nicely achieved. Let's assume that I have one file F1. Yes, I want to access this file. Means there is a file called as f1.txt. I want to read this file. Since it's a common resource, I have to make it synchronized. What is the necessity? Necessity is that we know when a person is writing into this file, another person cannot read from this file. Usually it is not allowed. You know, yes, any file, when you want to read it, at the same time, you don't allow somebody to write into this file. Then it is very nice choice. Sir, already it is solved. How? Sir, if this file f1.txt is read in the critical section by a P1 process, and this P2 process will be also write a lock and say that I will write into this F1 file, and then make a release lock. Then how it is easy, just see. If he wants to, if P1 wants to read, then he put a lock, do this, do the reading, and during the reading he cannot enter because he has put a lock, and same lock is used. He cannot enter into this lock. The moment he comes out by releasing the lock, he can enter. Or if he is present here, he cannot also enter. It's very nice choice. My f1.txt will be now SQL. If one is reading, another cannot be right. And this kind of things also written there internally in your operating system, because this is the way to do it. But it has one disadvantage. The lock says that once somebody take the lock, another person cannot enter. Let's assume in the same scenario you have written this code and P2 is not currently exist. If P2 is exist and he wants to write, this code is perfect. Let's assume P1 is only interested to read, and at the same time there is a P3 comes. The P3 also wants to read. Yes, this P3 also wants to read, but my code is same. Reading code is same. You enter into through this lock, read it, and comes out. This is the same code. Now the question, a difficulty comes into picture. What is that? One minute, somebody just go on. Yes, hello. Yes. After some time, I am in the class actually. Okay. Yes. So P1 and P3. Now, if P3 also wants to enter into this area for the reading purpose, you have to allow or not allow. Everybody knows. Can a two reading is possible? Yes, two readings is possible. N readings are possible. Means in this scenario, the P3 should be allowed, but he is not. Why? Because log says I cannot allow more than one person. Means log is not always satisfy our requirement. So I need something. What? Some cases I need a one person to be enter. In some cases I need multiple person to be enter. Yes or no? Because in this case only one person. Because if somebody is reading, somebody is writing, you cannot allow more than one. But if more two person wants to read, you allow him. You allow them to enter. So in this way, these things happen. So we need some other solution rather than lock, which will be satisfy our requirement. If it is a read and write, one person another. If it is only read, multiple person. How to do this? Okay, that is next class. That's all. Yes, if anybody has any question for 5 minutes, you can ask.
Sir, that arg PTR thing, can you show, sir?
Oh, sure. Arg PTR. Arg PTR. How to pass the argument, no? I was just opening. I'll just show you little things, not everything. Otherwise, will not try. So let's take marks, not marks. This is this. This is this. So check. You want the argument has to be passed, no? Huh?
Yes, sir. Means reference, means address of this thing.
Address of what? Address of what?
Sir, like address of integer of like integer addresses, sir. So we have to pass the variables as like pointer, no, sir, as address, no, sir, because the system call will change it.
System call will change it. Can you show me one problem? Some cases I thought about how to pass the command line argument.
Sir, that
it-
will happen through arg string, sir.
RC, RB, that you have to write.
Yes, sir. Sir, no, sir.
I think you have to write in this manner.
Yes, sir, that can happen, sir.
Huh.
Sir,
Then
for
which
example,
huh.
sir, in SPS, sir, I think we have to return multiple values from the system call.
Multiple values from the system call you want, huh?
Yes, sir. PID, PPID, name and state.
Sir, so we have to pass through reference only, na, sir.
But directly you can display it there. Not possible, huh?
The question, sir, that we have to pass these four and then we'll display that.
So through system call only we have to display.
Oh, through system call only you have to display.
No returning to the process.
Not returning, not required. If you want to returning, you have to create a structure.
Sir, our own structure, or can we use?
You have to create your own structure. You have to create your own structure.
Sir, and that data type was not matching, sir, because I created a structure and then I tried to assign that my proc's name and state, but
But my proc only gives a process, no? I'll tell you. That I understood. Now I understood your question. This my proc is returning a proc type. Yes, this proc is our what? Which kind of structure you know now? That is process control block. In the process control block, if you need something, then you have to pass that data. Like a PPID. How you can receive the PPID from this? Anybody?
Sir, my proc arrow parent.
Arrow mark parent, arrow mark P.
Parent and PPID.
Yes, PPID. So like this you can do it. I still am not getting. Can anybody share something so that I can help you?
Sir, today I have connected through phone, sir.
yes, sir.
Then when you can tell me.
Sir, I'll send you the screenshot, sir, in mail.
You can send me the screenshot and remind me once by calling. Yes?
Okay, sir, number?
Number आपको पता नहीं? My number is 94396.
Yes, sir, 94396.
27127.
Okay, sir.
Okay, you can just call me so that I can also give a time in the Zoom. We can meet and see also. No problem.
Sir, sir.
Sir,
I have a doubt, sir. Sir, जो हम SS cell में जो भी command run करते हैं, उसका PPID तो always same होगा ना, sir?
उसका PPID.
Yes, sir. जो SS का PID होगा वो same होगा. So, but sir, एक किस्म चेंज हो सकता है ना कि अगर SS cell में SS को रन करते हैं और उसके बाद कोई कमांड रन करेंगे तब तो चेंज हो जाएगा.
नो, वो चेंज हो, अभी भी चेंज होगा क्योंकि SS cell में कोई भी रन कराए वो एक डिफरेंट प्रोसेस है.
Yes, sir.
Then obviously उसका अगर चेंज होगा then उसका PID वही SS cell होगा.
Yes, sir. Yes, sir.
हाँ.
तो सर इसको कैसे रिटर्न करेंगे सर? मैंने अक्सर प्रोग्राम लिखा था सर proc.c में कि जो हमारा proc टेबल है उसमें सर एक स्ट्रक्चर डिफाइंड है. हमारे पास PID तो मालूम है तो PID से अपन सर्च कर लेंगे सर उसका नेम. सॉरी सर, नेम पता है ना अपन को, इसका नाम SH है. जो पॉइंटर का जो नेम स्ट्रिंग है उसमें सर्च करेंगे SH को. अगर वो होगा तो जो SH का जो करंट PID वो रिटर्न कर देगा. यस सर. बट सर मैं इसके लिए कंपैरिजन के लिए यूज किया था सर str कंपेयर फंक्शन. बट सर ये एरर थ्रो कर रहा है.
str नहीं होगा. string.h इसमें काम डायरेक्टली नहीं करता
सर, नहीं करता. तुम ट्राई करो, string.h नहीं कर रहा तो सर कैसे?
You have to manually check it. You have to manually write a function to check.
मैनुअली चेक करना पड़ेगा सर. अच्छा ठीक है सर.
सर वो ये printf में आर्गुमेंट पास, ये आर्गुमेंट वाला printf काम नहीं करता इसमें.
क्यों? वन वाला काम करता है ना. ऐसे लिखा हूँ, देखिए मैं जो लिखा हूँ आपको बता रहा हूँ. यहाँ पर कहीं पर मैं लिखा था ऐसे लिखा.
तो वो यूजर से लेना वो हेडर फाइल.
एक तो मैं गेट PPID रिटर्न कर रहा हूँ. देखिए तो
एक में काम नहीं कर रहा, वो यूजर एच में है।
हाँ देखिए 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 यहाँ पर जो कर रहा हूँ ये रिटर्न ऐसे लिखा हूँ, देखिए इट इज वर्किंग।
हाँ सर ऐसा किया था, लेकिन ये प्रिंट नहीं कर पा रहा था, वो सिर्फ वो सिस्टम कॉल में प्रिंट हो रहा था, वो सी प्रिंट वाला कुछ था।
नो, आप प्रिंट एप करके 1 करके दीजिए, वही प्रिंट एप लेकिन 1 कमा करके दीजिए, करेगा।
ओके सर।
ये 1 है, ये नॉर्मल प्रिंट एप नहीं है आपका। जैसे राइट फंक्शन है ना, कहां पर राइट कर रहे हैं एंड क्या राइट कर रहे हैं।
ओके सर।
ये बस देख लीजिए, काम करेगा। एंड रिटर्न तो यहाँ हो रहा है एज पर योर रिक्वायरमेंट, आई होप। ये देखिए इंट sys get PID ऐसे लिखा हूं, इट इज वर्किंग बिकॉज आई हैव रिटन दिस थिंग्स।
ओके।
ये जो चेंज करोगे ना, ये देखिए, ये जो चेंज करोगे, एक देख लीजिए यहाँ पर जो syscall.c में ना, syscall.c में एक्सटर्न इंट ऐसे लिखोगे, देख पा रहे हो?
हाँ सर।
हाँ, एक देख लीजिए, नो प्रॉब्लम, अदर्स यू हैव टू डू इट। कंट्रोल बी करता हूं तो पता चला, बट इट नो इन user.hist में तो आप गेट PPID करोगे, ये तो आपको पता है, इंट करके। syscall में तो डायरेक्टली sys.s में ये लिखोगे, then you have to set a number, any number. I said 22, you can give any number, huh? Then syscall.c में extern int sys get PID this. Oh sorry, got it, this one.
उसको उसके अंदर वो कॉल करेगा।
हाँ, उसके अंदर। और यहाँ पर तो डायरेक्टली लिखोगे sys get PID this, इसमें तो कुछ चेंज नहीं करना है। जब आप sys get PID लिखोगे वहां पर int भी लिखोगे, ये थोड़ा नीचे चला गया है, int this।
सर इसमें कोई कन्वेंशन है क्या ऐसे लिखने का, वो रिटर्न टाइप ऊपर, फिर फंक्शन का नेम, फिर उससे
नहीं नहीं, ऐसा कुछ नहीं, ऐसा कुछ नहीं। यूजुअली स्टाइल ऑफ राइटिंग इज लाइक दिस अर्लियर, इट इज अदरवाइज ऐसा कुछ नहीं, क्योंकि मैं वहां से कॉपी करके एक वार फाइल में लिख रहा था तो इसलिए कॉपी।
नहीं सर, कोड में भी ऐसा था इसलिए बोल रहा हूं।
हाँ।
ओके सर।
ओके, पता चला अभी रिटर्न अभी कर पाओगे शायद? हाँ
यस सर।
यस, somebody has argument still मैं समझ नहीं पाया थोड़ा।
सर ये जो सर एक ही वैल्यू रिटर्न कर रहे हैं ना सर, तो मल्टीपल रिटर्न करने के लिए जो स्ट्रक्चर बनाएंगे सर, सर उसमें वेरिएबल्स का डेटा टाइप क्या लेंगे? PID PPID के लिए INT ले सकता है,
INT ले सकते हो,
और सर नेम एंड डेट के लिए सर कैरेक्टर एरे लेंगे,
कैरेक्टर एरे ले सकते हो।
वो लेकिन असाइन नहीं हो रहा था नेम और स्ट्रिंग वाला।
नेम और स्ट्रिंग उसको मालक नहीं किया है, असाइन नहीं होगा। आपको कैरेक्टर एरे लेने पर तो असाइन होगा, कैरेक्टर पॉइंटर लेने पर असाइन नहीं,
असाइन नहीं हो रहा था सर इसलिए।
लेकिन इंटीजर सब हो रहा था।
हाँ सर,
ओनली कैरेक्टर नहीं हो रहा था
सर।
हाँ, एक का डाउट, उसके बाद आपका। हाँ
सर मैं जो डाउट पूछ रहा था वो आर्गुमेंट पास करने का सर, वो ये था कि जैसे सर मतलब यूजर प्रोसेस से कर्नल में डायरेक्ट आर्गुमेंट पास नहीं करा सकते ना सर?
नहीं आपको नहीं, वो भी कर सकते हो ना, वो भी कर सकते हो, मतलब
नहीं होता है वो।
नहीं मैं जो मानो 5 मिनट ज्वाइन कर, देखिए ये जो मैं किया हूं, जो गेट PPID किया हूं, समझ में आ रहा है? इसमें क्या हो रहा है कि रिटर्न वाला आपको पता चल गया, आपको अभी करना है कि गेट PID में अगर कुछ पास करना है, दैट यू वांट नो?
यस सर, हाँ एड्रेस पास करना है।
यस, आपको एड्रेस या कुछ वैल्यू पास करना है।
यस सर।
एड्रेस क्यों पास करना है
सर? तभी तो सर चेंज होगा ना सर वो आर्गुमेंट जो पास किए हैं।
तो अगर एड्रेस पास करने के लिए नहीं देता है, आप पैरामीटर रिसीव करके उसमें सेट कर दीजिए।
पैरामीटर इंट में रिसीव करके उसको फोर्स मतलब कन्वर्ट कर देंगे,
कन्वर्ट कर दोगे। अगर वो ऐसे नहीं करता है, मैं चेक नहीं किया, बोल रहा हूँ। यस, अगर वो ऐसे नहीं करता है, आप इंट के थ्रू पास कीजिए, इंट के थ्रू पास नहीं होता है, इंट के थ्रू पास तो हो पा रहा होगा
सर। आर्ग इंट यूज करना पड़ता है उसके लिए भी।
हाँ, वो यूज करोगे क्या? देखिए, और एक किया हूं, रुकिए कहां पर है, एक मिनट। यहाँ पर सिस्कोलोइड यहाँ पर तो पास किया हूँ, ये मत देखिए। हाँ ये तो वो एक PID पास किया हूँ,
वही सर, आप भी सर आर्गेंट यूज किए हो सर?
हाँ, ये इसमें यूज किया होगा, मैं अभी और देखा नहीं। समथिंग आई एम यूजिंग। कहाँ पर आर्गेंट बोलिए तो यहाँ पर, हाँ यहाँ पर गेट पीआईडी हो गया, फॉर्क हो गया।
आर्गेंट क्या होता है?
उसी से मतलब वो सूडो फंक्शन है जिससे मतलब इंटीजर पास
आर्गेंट
होता है।
आर्गेंट क्या होता है कि जब ये मल्टीपल आर्गुमेंट होता है वो उसके थ्रू भी एक्सेस करते हैं हम लोग।
ओके सर, वो वाला वेरिएबल आर्गुमेंट।
वेरिएबल आर्गुमेंट टाइप का ही है तो, हाँ सही बोले, जो ट्रिपल डॉट होता है ना, एलिप्सिस बोलते हैं उसको, उसी टाइप का। लेकिन मैं पास किया हूं कहीं पर एक, ये तो रिसीव डायरेक्टली कर रहा हूँ वेट पीआईडी में। कहां पर आर्गुमेंट फिर चाहिए बोलिए
सर सिस्कॉल वेट पीरियड सर, यहाँ तो सर वॉइड है उसका भी।
नहीं, इसका वर्ड है लेकिन पास कर रहा हूं मैं। यहाँ पर वर्ड लिखना पड़ता है लेकिन पास किया हूं।
यस सर, आप पीआईडी में सर वो आर्गुमेंट का सर आर्गेंट, इफ आर्गेंट 0 वहां से सर किया हो सर कुछ।
हाँ आर्गेंट, हाँ यहाँ से, हाँ ये वाला। यहाँ से मुझे पीआईडी मिल जाता है।
यस सर, इंट पास हो जाता है पर सर एड्रेस पास नहीं हो पाता वैसे।
और नॉर्मली एड्रेस नहीं पास होता है। हाँ ओके, मैं देखूंगा फिर।
सर उसके लिए सर आर्ग पीटीआर यूज करना पड़ता है, उसका सर टेक्निक नहीं समझ आ रहा सर, और उसका कोई रिसोर्स भी नहीं है इंटरनेट पे, मतलब मिल नहीं रहा है।
आपको क्या चाहिए? आर्ग पीटीआर ना? मैं देखूंगा आज, हाँ देखूंगा, क्योंकि
सर
मैं भी सीख रहा हूँ। यू डोंट थिंक दैट आई ऑल्सो नो एवरीथिंग, बिकॉज वो ऑपरेटिंग सिस्टम बहुत लोग बनाए हैं, तो यू हैव टू आर्ग पीटीआर चाहिए ना आपको, मैं बताऊंगा।
सर मैंने आरपीटीआर में सर सिंगल एड्रेस पास कराया तो वो हो जाता है सर, मल्टीपल में दिक्कत होता है।
पीटीआर में सिंगल एड्रेस पास करने से हो जाता है? हाँ
यस सर,
मतलब इंटीजर टाइप का एड्रेस।
यस सर, सिस्टम कॉल में सर जो डिफाइन करेंगे ना वेरिएबल सर, वो डबल पॉइंटर रहेगा तो हो जाता है।
वो काम कर रहा है?
यस सर, वो मैंने ट्राई किया।
वो तो बोल रहे हैं काम कर रहे हैं, फिर उनका थोड़ा हेल्प लीजिए।
सर मल्टीपल नहीं होता है सर, मल्टीपल वैल्यू अगर पास करना ना एक साथ तो नहीं होता है।
मल्टीपल वैल्यू मतलब क्या है?
जैसे एक साथ अगर मल्टीपल वैल्यू पास करना, जैसे अगर 3-4 एड्रेस है, एड्रेस पे एड्रेस बी एड्रेस सी, तो नहीं होता है सर।
ओके, उसको आगे में रख के, उसका आगे में रख के पास कर।
यस सर, ये हम ट्राई किए थे सर, ये हम ट्राई कर रहे हैं सर, इसको मैं करेंगे सर एग्जीक्यूट, एरे में बेस की करेंगे सर इसको,
आगे में पास करके कीजिए, शायद हो जाएगा।
यस ठीक है,
क्योंकि वो जिस स्टाइल का लिखे हैं हमको उसी स्टाइल का ही सीखना पड़ेगा, नहीं तो नहीं कर पाएंगे। ऐसे नहीं कि हम सी जानते हैं मतलब हम कर पाएंगे पूरा। वो जिस हिसाब से रिसीव कर रहे हैं, जिस स्टाइल से फॉलो कर रहे हैं, हमको उसी स्टाइल से फॉलो करना है।
यस सर, यस सर।
इसलिए वी हैव टू रेफर मेनी कोर्स फ्रॉम देयर OS, देन ओनली यू कैन डू दैट। अदरवाइज ये तो डायरेक्ट सिंटैक्स जैसा नहीं है। ओके ठीक है, ए वाला शायद आप कर पाओगे। ये रिटर्न हो गया। ओनली आरपीटीआर का कुछ कोई पूछे हैं, मैं देखूंगा ये वाला। और आपका जो वो बोले थे मुझे स्क्रीनशॉट भेजेंगे, कोई एक तो बोले थे। हाँ
यस सर, मैं ही बोला था।
हाँ ओके ठीक है
सर वही मतलब एड्रेस, मल्टीपल एड्रेस मतलब पास करा, वही मतलब उसी का स्क्रीनशॉट भेजूंगा अगर भेजूंगा तो सर, वो
हाँ
वही
हाँ
सर।
उसी का नो।
ओके सर,
थोड़ा कोड भेज दोगे तो मेरे लिए इजी होगा कि मैं उसको डाल के भी चेक कर पाऊँ।
ये सर कोड भी भेज दूंगा सर,
हाँ।
सिस्टम कॉल का भी और
तो मुझे
मतलब कमांड का
टाइप
भी।
नहीं करना पड़ेगा, मैं उस कोड को डाल के फिर चेक करूंगा कि हो रहा है।
यस सर।
Okay then, I'm ending now. Fine. Thank you.